Great one. So in this video, we're going to talk about the text classifier that we build in the laboratory. So um, in the laboratory, having a desk is important, especially for our natural language processing in PyTorch. So what we're building is the text classifier that, like for example, if we input the recipe title like banana smoothie, it is output as 0 or 1, 0 for vegetable and 1 for fruit. So this is a binary classification problem in natural processing, language processing. So here's the full pipeline. In the laboratory, um, from the raw text into cleaning, into tokenization, to vocabulary, into the numbers, into the model, and to prediction. So in text, from text to number, um, computers cannot understand text, so we convert words into numbers. Examples: the apple pie text, we split into the apple and pie, and those two tokens has numerical values, like for example 12 and 45. This mapping is called a vocabulary or word to index. So in its index value, for example, is in the apple is 12 and the pie is 45. So why this matters? So each word gets a unique ID. These IDs are used for embeddings later. Next is avoiding data leakage. So we build the vocabulary only from training data. Um, um, Sometimes it is wrong to think that it's using test data to build vocabulary. So the correct one is to train data to build vocabulary, and to test data to use the same vocabulary. Why? Because otherwise your modeling is cheating, seeing future data. So next is dataset and data loader. We create a custom dataset. It handles storing text, converting text into tokens to indices. Here's the data loader. It handles batching, shuffling, and efficient loading. So the problem is the text lengths vary. Example: apple is one word, and in the sentence banana chocolate smoothie is 3 words. We cannot stack them directly, so the solution is collate function. This is one of the most important parts. It processes the batch manually. It handles variable length sequences. Next is embeddings, the core natural language processing idea. Instead of using raw numbers like 12, 45, we use embeddings. It is dense vector. Like for example, the apple is a combination or consists of different numbers that represent it. Like for example, 0.2, negative 0.1, 0.9, and so on and so forth. And banana is 0.25, negative 0.5, negative 0.78, etc. Similar word is similar vectors. Next is two approaches in here. So n embedding bag. This is a fast plus optimized layer. It takes word indices directly, computes pooled embeddings. Now to pad sequences. Next is manual embedding plus pooling. Steps is we convert words to embeddings, combine them using mean pooling and average. Max pooling is strongest signal, sum pooling is total signal. So next is model architectures. We compare multiple models, like model 1 is embedding bag model, fast and efficient, text to embedding bag to linear and to output. Next model is manual pooling model. Its pipeline is text, from text to embedding, from embedding to pooling, from pooling to linear, from linear to output. So the pooling types is mean, max, sum. Next is class imbalance. So dataset has more of one class. Example given to vegetables, and the fewer of another is fruits. So the problem is model becomes biased, always predict majority class. So the solution here is class weights. Using the code from the scikit-learn utility class, where we import the complete class weights. Then apply to loss. So the loss function, we use the cross-entropy loss, and we use it into the formula of the loss function, the class weights. So here's intuition. Rare class is higher penalty if misclassified. Next is training loop. The standard PyTorch training is steps is forward pass, next is compute loss, backpropagation, and update weights. Here's the code pattern. Optimizer, that's zero grad. The output is model inputs, the loss, the loss function, and backpropagate, and optimizer step. Next is evaluation metric. This is of F1 score. Instead of accuracy, we use the F1 score. Why not accuracy? Because dataset is imbalanced. Example, 90% vegetables, and model predicts always vegetable. It's a 90% accuracy. So F1 scores balance, precision, and recall. Next is model comparison. We compare embedding bug model, min pooling model, max pooling model, sum pooling model. So the goal is to find best F1 score. So final testing is after training, we test on unseen recipe titles like mango shake, it is classified as fruit. Grid zucchini is vegetable, as classified as vegetable. Next is this is a real key takeaways here. First is tokenization. We split text into two words. Next is vocabulary. It maps words into numbers. Embeddings is from words to vectors, and batching variable length text using collate function. Next is pooling. Combine word vectors into one vector, so we have more memory efficiency, and we we reduce the spatial size. Next is class imbalance handling using class weights. F1 score and accuracy. F1 is better for imbalance. So here's the common mistakes is using test data to build vocabulary, forgetting to handle variable lengths, using accuracy and unbalanced data, not applying class weights. So this is simple mental model. Think of your model like this. Sentence is a bag of words, words is vectors. Combine vectors in one meaning, classify the meaning, and that's it.